If someone asks you to differentiate this equation, what would you do? Any normal way that you would try to differentiate this wouldn't work, so we use a special application of implicit differentiation called logarithmic differentiation. It involves taking the natural log of both sides of the equation and then simplifying it into a form that's easy to differentiate. Let's try this with x to the power of x. We can solve this by taking the natural log of both sides of the equation and bringing the exponent down to the coefficient. Next, we can take the derivative of the entire equation and differentiate the left side using the implicit differentiation. The next thing we have to do is use the product rule. Product rule, as shown above, allows for you to take the derivative of a product of functions. Using the product rule, we can differentiate the right side of the equation, do a little bit of simplifying, and then multiply y to isolate y prime. However, we don't just want y, so we can replace it with the original function as defined, which was x to the power of x. Now let's do some examples. Okay, let's do this example. So, as we can see, this is an x, a variable, to the power of another x, another variable. And when you see this, you can't differentiate this in any normal way. You would need to use logarithmic differentiation. Now, let's try this out. Let's write down the equation. Y equals 2x to the power of 5x plus 4. So let's take the natural log of both sides. Y equals natural log of 2x, 5x plus 4. Now we know from log rules that the log base anything of x to the power of something like b. This exponent can go down over here and be written as b log base a of x. So knowing this, we can see that this is an exponent. We can bring this exponent down to this side and rewrite it as natural log of y equals 5x plus 4 times the natural log of 2x. Now this simplifies a lot, but we still have this natural log of y, which we're going to need to use implicit differentiation for. Let's do that right now. Let's take the derivative of this entire function. And because of that, we can just kind of take the derivative of each side of the equation, doing something like this. And before we look at this right side, let's look at this left side first. As we know from implicit differentiation, and since we're taking the derivative of y with respect, or of a function of y with respect to x, we need to use implicit differentiation. Now, the way to think about this is think of y as a function of x, because it's this function of x. But let's not look at that right now. Let's think of it as just f of x. And what we're having here is a function of y. So let's not use f, g of y. What we're also saying about that is that's g of f of x. And we know using the chain rule that the derivative of this is equal to the derivative of g prime of f of x times the derivative of the function inside. Now in this case, our f of x is our y, and our f prime of x is going to be y prime. And using this, we can say that the derivative of the natural log of y would be the natural log of f of x, which is equal to 1 over f of x times f prime of x, which in this case would be y prime over y. Now we're reaching to the bottom of the screen, so I'm going to erase this and bring this back up to the top. So now we have our derivative of this left side. That was the hard part. Now look at this right side. With this, we're just doing the product rule. We can take the derivative of this f of x, which will be 5, multiply it by the original function on this right side, which is natural log of 2x, and then add it to 5x plus 4, this original equation from this side, times the derivative of this, which ends up being 2 over 2x, or 1 over x, right? So now we're reaching the home stretch. We can just solve this out. Y prime over y equals 5 natural log of 2x plus 5x plus 4 over x. Not much simplifying to do, right? And what we're trying to find is this y prime. That's what the derivative of the function is. But right now we have a y prime over y. Now, we can do this, we can just isolate y prime by doing our normal algebra 1. You can multiply this on both sides, and then you isolate y prime. So let's just do that. Let's do that. First, let me move this thing down a bit. Y prime is equal to y times 5 natural log of 2x plus 5x plus 4 over x. But we don't want this y here. Honestly, this y, we're trying to find y prime in terms of x, and we don't want this y. But we know, as defined up here, y is equal to 2x to the power of 5x plus 4. So we can actually just completely erase this y. I'm just going to rewrite this y. We can erase that y and replace it with 2x to the power of 5x plus 4. And boom, there's your answer. That's example 1. Okay, second example. Now, this is a little bit of a different example. One would think that, hey, this is just a normal function. I can take the derivative of this normally by using the chain rule and then a quotient rule. And you can do that. You would get the same answer, but you would also go through a lot more steps than you would be using something like logarithmic differentiation. And it's actually really interesting how you can simplify these. So let's see it. Y equals x over x plus 1, right? Let's rewrite this as y times or y equals, my bad, x over x plus 1 to the power of 1/2. Now, if we were to do this normally, we would use the power rule and then multiply this by the quotient rule and all of that fun stuff. But in my opinion, I think it's more interesting and also sometimes easier to use logarithmic differentiation. So let's try it. Natural log of y equals natural log of x over x plus 1 to the power of 1/2. We can use the log exponents rule and bring this down to the coefficient. Natural log of y equals 1/2 natural log of x over x plus 1. And if you remember from algebra, you would know that the natural log, or any log for that matter, of some function over another function is equal to the difference of the two parts. So natural log of f of x minus natural log of g of x. And that'll help us here. It'll simplify things a lot. We won't have to use the quotient rule. Natural log of y equals 1 over 2 times, make sure to keep this in parentheses, natural log of x minus, because you have this division, minus the natural log of x plus 1. Now we want to keep everything in parentheses just to make sure we don't make any silly errors. And now let's take the derivative of this. Actually, you know what, before we take the derivative, let's expand this and make sure that we're not going to make any mistakes. Let's just distribute 1/2 natural log of x minus 1/2 natural log of x plus 1. Not too bad. Now we can take the derivative of this. Start from here again. As we know from the last example, the derivative of the natural log of y is equal to y prime over y because of the chain rule and determining y as a function of x. So y prime over y is equal to the derivative of 1/2 natural log of x minus 1/2 natural log of x plus 1. Close brackets. Y prime over y equals, and now we can just differentiate this like normal. 1 over 2 times 1 over x minus 1 over 2 times 1 over x plus 1. Simplify further. Y prime over y equals 1 over 2x minus 1 over 2x plus 2. That's 1 over 2x plus 2. And then as we know last time, we want to isolate y prime. We want to isolate this. So we can multiply this y onto this side and we get y prime equals y times 1 over 2x minus 1 over 2x plus 2. And we can replace the y with, as originally defined, we can replace it with this. So we get everything in terms of x. And so we get y prime equals square root of x over x plus 1. I'm gonna erase this arrow, it's kind of useless. Square root of x over x plus 1 times 1 over 2x minus 1 over 2x plus 2. And this is our final answer. And personally, I think that was easier and just less taxing to use the logarithmic differentiation instead of the product rule. Or, sorry, quotient rule. And that's example 2. Let's go on to example 3. Okay, third example. This one looks scary. You can see that there's a product rule here, e to the x. You have a trig function in the power. What am I going to do with this? Now, the key to solving this problem is to make sure you know exactly where everything is. Make sure you're organized, make sure your parentheses are in the right place. The logic in this problem isn't the hard part. It's going to be the organization. So let's just get right into it. Y equals x cubed e to the x times cosine 2x, and that we can take the natural log of both sides. Natural log of y equals x cubed e to the x cosine 2x. Take the natural log of both sides. Natural log of e to the x cubed e to the x cosine 2x. Do the product of logs. I'll do it right here. Natural log of y equals cosine 2x. Natural log of x cubed e to the x. Now, since this is multiplication, we can actually add the product of the logs. So we can just do natural log of y equals cosine 2x times the natural log of x cubed e to the x minus or plus natural log of e to the x. Now we could use the power of logs on this, but honestly I think it's just keep it like this. If it's really complex we can do it, but honestly I don't think it's worth it to just do the log and then continue on. So I'm gonna keep it like this. So let's take the derivative of both sides. Let's do it over here so we have more space. Y prime over y, as we know, is the derivative of this part, is equal to derivative of cosine 2x times the natural log of x cubed plus natural log of e to the x and the product rule. This is going to be the hardest part, and where a lot of people, including myself, make mistakes. Everyone makes mistakes on this, so the key is to be organized and not miss anything. Let's do the product rule. I'm just going to do this derivative and ignore this for now. So let's do it. So the derivative of cosine is negative sine 2x multiplied by the chain rule, so it'd be negative sine 2x times 2 because of the derivative of this inside function, multiplied by the natural log of x cubed plus the natural log of e to the x plus cosine 2x times the derivative of this entire thing, which will be 1 over x cubed times the derivative of x cubed, which is 3x squared, plus the natural log of the derivative of the natural log of e to the x, which is just x. But let's do it. 1 over e to the x times e to the x hold on, did I? No, I didn't. Okay, this is right. Hopefully. So we can multiply it by natural log 1 over e to the x, multiply by the derivative of e to the x, which is just e to the x. Cancel these out. Cancel these out. Okay. And we get, this is going to be fun, negative 2 sine 2x times the natural log of x cubed plus natural log of e to the x plus cosine of 2x times 3 over x plus 1. And honestly, let's simplify this inner natural log. For this part, we'll get 3 natural log of x. And for this, we'll actually just get x. Whew, and that's this part. And now we just have a pretty simple part left. This is going to be pretty squished. We're going to go back to this, multiply y on both sides, and we get y prime equals y would be, in this case, x cubed times e to the x cubed times e to the x cosine 2x multiplied by this entire thing, which negative 2 sine 2x times 3 natural log of x plus x plus cosine 2x times 3 over x plus 1, and we have solved it. This is our answer. Huge problem. Hopefully I didn't make a mistake, but this should be the answer if everything went according to plan. Hard problem.